Hi, video 18. This is indirectly on the North South Interconnector, but it's more about interconnection generally and to get the principle across, and it's related to video 17C, which gives an idea of a particular plan that was hatched up by the Irish government. But this is more, maybe gives a better view and lets people understand something that is very difficult to get to understand, but hopefully I can do it here. We have two islands. A is occupied, B is not. But for some reason there's, we'll say, silver in low amounts on this island, and it's run out. And so that's their income. And they have a perfectly good 1000 megawatts fossil fuel plant there for generating three-phase alternating power. And they decide to abandon the place, and they want to move over to Island B with a few extra people or whatever. And Island B has discovered new deposits of silver, so they're going to mine there and do all the various things. So they decide to move over completely. And instead of building a new power station, they decide to bring the 1000 megawatts from A through an alternating current line to B. And they can afford and get a 1000 megawatt AC line. And that's what's decided on. So they leave a few people behind to generate, and they generate 1000 megawatts of alternating current, three-phase, and they send it over here, and it's received the other end as fossil fuel 1000 megawatts AC three-phase power over there. The only process is this has to be stepped up in an alternator and stepped down this side. That's all. The frequency is identical on both places, and a wire brought from here to here would not melt or anything because the two are in exact phase. So the frequency is the same. So if you can keep this at 50 hertz, this will be at 50 hertz. And so long as you don't put the load above 1000 megawatts, happy days. So you could use less and all that sort of stuff by just taking it apart. But anyway, you're aware with it as long as you don't overload the system beyond this, everything works well. The problem there is AC lines under sea have problems, and we'll deal with that at another time, particularly with capacitance and other losses. Another thing called skinning. Now, what we're going to do now is we're going to change now, and we're going to change this for a DC line. So instead of having an AC line, they have a 1000 megawatt DC line. And when they take this here, they have to rectify it and make it into DC power, 1000 megawatts, and lay it across. But when it's arrived over here, it's converted to AC power. This will not work because the inertia is not brought over with it. The inertia is in the heavy rotors here. All you get is the electricity from them, but you do not get any of the grid stability, because grid stability cannot be transmitted over DC lines. Okay? So now we change here, just turn this around, and we now see that they have agreed to take off all the output of their old island, and they have 1000 megawatts of DC non-synchronous power, but they have to add 670 of their own. They have to set up a fossil fuel power generator of their own with three-phase alternating current, stable, synchronous, in order to get it up to 40%, which is needed in any system. There must be 40% of synchronous power. There can be 60 of non-synchronous power. And so the shortcomings of the DC line are seen. So now they have 6, 7 and 1000 is 1670. 1670. Right? And they mightn't need that at all. If they do need it, that's alright. So you see straight away how you have to start generating fossil fuel three-phase power in order to use the DC power, irrespective of what the source of the DC is. Because this does not contain the stability, grid stability, and the inertia needed to stabilize the system. So now we're going to stop this. We're going to just leave it running and hopefully just show you now. We're going to now turn this island green. Okay? We'll turn it green. So we can only export 1000 megawatts. And so we need to put up windmills. So we have our wind farms built, but we need 40% fossil fuel, along with the 60 to bring up the 1000. We cannot export the 1000 because it needs to be stable, 3-phase, inertia, synchronous power. It has to be rectified down to DC. It will not go in there unless it's proper power, like we have in our own system, and let in. There has been cut-offs and shutdowns of the East-West Interconnector at Rush when this becomes a bit unstable. So you need stable power, and that has to contain 40%. So I think I have the number on the wrong side. Yeah, here it is. That has to contain 400 megawatts of fossil fuel power, bringing the whole lot to 1000. Now you can let it across, and when it's received on the other side, it's the same as the earlier example. It doesn't matter what the source of this is. What's received here is 1000 megawatts of non-synchronous power in AC, in DC, in direct current. It's inverted back over then to alternating power, 3-phase. So it's alternating. It's grand in every respect, except that the weight of the inertia in this island are not transmitted over the DC line. And this is the very same as our belt. The 3-phase line transfers the inertia and the frequency and all by means of the cogs. Do you see them there on that? See them on that? Yeah, see that? And there's no slippage. No slippage. Whereas an ordinary fan belt has slippage. So while the fan belt will transmit most of the power, it will not keep the two pulleys exactly in line. So this will not transfer the inertia that's needed to keep this system in line with this system and in frequency. So 670 has to be added to 1000 to give 1760. Okay? So now we see that we had to change our 1000 megawatt island A to 60-40 wind and 40 fossil fuel, and then at the other end we had to change our 1000 megawatt to 1670 to give 1670, which is roughly 1640, but we now have an excess. Now if we add, for this example, remember now we generated 1000 here comfortably. We now have to use 1670 over here because of this problem. So the amount of wind, the amount of wind here is 40% or 400. Okay? The amount of fossil fuel power, synchronous power, is 40. The amount over here is 670. And that brings us to 1070 generated by fossil fuel. So we're now generating more fossil fuel than we were before we sent it over, even though we have extra here. Okay? So the total wind is 600, but the total output is 1670. It's still the majority of fossil fuel. And this is the problem you get when you want to change into DC. Not only do you have to add 40% when you generate it and export it, you have to add 40% ratio. You have to bring, this here has to be a ratio of 40-60. Letting it out, exporting, and the receipted final amount has to be 40-60. And this here is 1670 and this is only 1000. So you have, again, 40 and 670 is 1070 of fossil fuel, right, for to use 600 of wind. Now I hope I've made that fairly clear. I think that kind of concentrates it on without going any further. I don't think there's any more need. All you have to remember is that each time it moves across the DC lines, it has to have 40% fossil fuel in it. And when DC arrives at the other end and is put ready for the final use, it has to have 40% fossil fuel extra in it. Now in the UK and in East-West Interconnector, there may already be tucks of this fossil fuel plant in existence. So a bit of wind may act like the fan belt lifting the system and may do some good over there. Okay? But this is the basic principle. And the North South Interconnector, according to the documentation, is partly for grid stability, but it's also for to accommodate 600 megawatts of wind generated electricity in the northwest of Ireland. Right? So it would then go down to Northern Ireland. Now, if a DC line is used, this problem arises. They will have to generate this ratio, 40-60, in Northern Ireland to accommodate the 600 coming in. See that? So 600 here is generated in the Republic and sent through a DC line to the north would require 670 fossil fuel to be generated in the north, and then they'd have an extra amount of their own and this, and they'd actually be using a component of this would be fossil fuel. So as I pointed out there, there'd be 1,070 of it fossil fuel just to accommodate this 600. So that's if you use a DC line. And there was a lot of talk about undergrounding, and I kept asking this question: are you on about DC or are you on about AC? And at the oral hearing in the Newmore Hotel in Carrickmacross Cross into the interconnector planning, I rubbished this and I agreed this cannot work. And the groups involved in it should have made it clear what they're talking about. Now, if they're talking about direct alternating current, then the pylons that are being built are alternating current. We can't deny that's the most suitable. But then, if we're putting them on the ground, we're into another scenario whether they can be put on the ground, and they can actually be put on the ground. So we might look in another video at what's involved there. Okay. But hopefully now I've explained that to get that into our heads. Direct current in the Irish situation will not link the two north and south together. If you brought a wire from County Monaghan into County Armagh from two houses, a cable or something, it would burn because the two systems are not exactly in the same frequency, even though they are 50 hertz. Whereas with the AC, if this is strong enough to form a backbone, then this would set the frequency of the two systems. The two systems will be the same on the whole island. So then we're only down to one simple thing, and that is whether you can put this on the ground or not. And we deal with that in another video. So hopefully I've made that clear. I've got that across. It's very, very important to understand that concept. So thank you very much. It's 13 minutes. We didn't do so bad. I'm glad to get that done. Thank you.